अस्सलाम वालेकुम स्टूडेंट, इट्स today's थर्ड लेक्चर. सॉरी आई वाज बिजी इन मीटिंग, तो अभी फ्री हुआ मैंने कहा आपको लेक्चर रिकॉर्ड कर दूं. सो नाउ द केमिकल रिएक्शंस ऑफ अल्कोहल्स. सो अल्कोहल्स आर versatile compound. They react both as nucleophiles and electrophiles. They have both the properties of, because if there is OH bond cleavage is broken, then alcohols react as a nucleophile, and the bond between CO is broken, then they act as a electrophiles. So how they act as a nucleophile? So reaction is given when they react as carbon cations. Definitely it will make bond with carbocation with lone pair of electron. Resulting bond will be established between carbocation and oxygen, and with the replacement of hydrogen. Now this is the protonated alcohol as electrophiles. These act as electrophiles when alcohols are subjected to the acidic media. Then hydrogen coordinate with the oxygen, it become OH2 plus. Then like if anyone, a group that can replace this OH can attach itself to these alcohols and replacing the OH. Now reaction involving cleavage of OH bond. Acidity, the one is the acidity of alcohols and phenols. Reaction with, first of all, reaction with metals. Alcohols and phenols react with active metals such as sodium, potassium and aluminium to yield corresponding alkoxides, phenoxides and hydrogens. Here is the reaction between the alcohol with the presence of sodium. It forms sodium alkoxide. This sodium alkoxide, then this is a tertiary butyl alcohol in the presence of aluminium. This is another reaction with metals. Again it forms butoxide, that is the alkoxide. And the third one is the phenol. When reacted in the presence of sodium, it forms sodium phenoxide. Acidity of the alcohol. Acidic character of the alcohol is due to the polar nature of OH group. An electron releasing group increases electron density on oxygen, tending to decrease the polarity of OH group. This decreases the acid strength. So keep in mind, electron releasing group like CH3, C2H5 increases electron density on oxygen, tending to decrease the polarity of OH group. This decreases the acid strength. So when polarity is decreased, its strength as an acid decreases, like the primary alcohol, secondary alcohol and tertiary alcohol. Alcohols are, however, weaker acids than water. This can be illustrated by the reaction of water with an alkoxide. So when we react alkoxide with water, they form conjugate acid and they form conjugate base OH. So this behavior shows that alcohols are weaker acid than water. The reaction shows that water is better proton donor than alcohol. Also in the above reaction, we note that the alkoxide ion is better proton acceptor than the hydroxide ion, which suggests that alkoxide are stronger base. Acidity of these are different phenols. Now alcohols and phenol react with carboxylic acid chlorides and acid hydrides to form esters. So ester formation when alcohols, well, these are aromatic or aliphatics. When they react with carboxylic acids, they form acid chloride and hydride to form esters. So here is the reactions of these alcohol, general reaction which these esters are formed. The reaction with carboxylic acid anhydride is carried out in the presence of a small amount of concentrated sulfuric acid. The reaction is reversible. Therefore, water is removed as soon as it is formed. The reaction with acid chloride is carried out in the presence of a base neutralize HCl, which is formed during the reaction. It shifts the equilibrium to the right hand side. The introduction of acetyl group in alcohol or phenol is known as acetylation. Acetylation or salicylic acid produces aspirin. This is a very much important reaction for synthesis of organic compound, which is generally used for the synthesis of organic compounds.